fraction. But if it's a fraction that is, you know, a non-repeating decimal, 1/2, 1/4, something like that, you want to put it in 0.5 because it's quicker to type, go for it. Doesn't make a difference. So I'm just going to put in 0.5 to the x. And I want to just look at the graph. What's different between this graph versus the graphs we did yesterday? It's going the other direction, isn't it? Your growth graphs from yesterday were moving from left to right, moving up, or moving from left to right, moving down. Decay problems are opposite that. Moving from right to left, it goes up. Right to left, it goes down. That's what the difference between decay is. And the reason that is because the variance upon the b value. The b value denotes whether it's going to be growth or decay. Growth has b values greater than 1. Decay has b values between 0 and 1. That's the difference between growth and decay. Everything else is identical. Your parent functions are the same. The way you shift is exactly the same. The way you move your asymptotes is exactly the same. None of that changes at all, guys. The only thing that's different is that b value. Sir?
What if it's less than 0?
If it's less than 0, that means your a value is negative. It's a great question. Everybody hear that? This came up earlier today also. What happens is if you have a b value, let's say it's -3 to the x, what's your a value then?
It's -1.
It's -1, so that means it's y equals -1 times 3 to the x, so it's still growth, isn't it?
So b is always positive.
Right. Good question, Clay. Does that make sense though, guys? All right. So the variance upon the problem then, whether it's going to be a growth or decay, is just within b. We plot and do everything exactly the same, guys. This is not going to take us very long to get through. All right. Let me show you an example. Oops. Then I'll show you the nice little shortcut about what you can do with an equation. Excuse me. So we have y equals 5 times 1/2 to the x plus 2. Just like we did yesterday, I want to get you guys in the habit of identifying your a's, h's, and k's. When we get into trigonometry, we're going to be doing a, b, h, and k. In this instance, the b value, we don't really need to write it down. We can observe it. So what's a, h, and k in this case?
A is 5.
5, 0, 2. So I also know that then that this is going to have a shift. What way?
2.
It's just going to go 2 up for my shift. There's no horizontal shift here because it's 0. You're all right with that?
Yes.
Parent function. Your parent function is always going to be this. Your parent function is always going to be y equals a b to the x. Nothing else. All right. In this case, it's 5 times 1/2 to the x. We still pick the easy numbers. -2, -1, 0, 1, and 2. Still works, doesn't it? And the only thing that you have to be cautious of here, guys, is when you're working with your fractions with negative exponents, what do you do to the fraction? You flip it. Okay? So 1/2 to the -2 becomes 2 squared. Do you remember that rule? Yeah. So what's 5 times 2 squared? 20. 5 times 2. 5 times. Oh, look at that. It's your y-intercept of the parent graph. It's still a. Dun, dun, dun. And then be 5 halves, and then 5 fourths. Okay. So let's see, we have 5 and 20. Oh, I'm sorry, negative 2 and 20. So let's see. Negative 2, 20. Negative 1 and 10. There's a joke that nobody even chuckled at.
Because you don't have enough space.
I already used them.
I was trying to be funny, and I went negative 2 and I went 20.
Okay, no. Noted.
It was funny, nice job.
It's a tough crowd today.
Yeah.
Screw you all.
I failed these. I failed
Where's your asymptote? Boo, yeah. Boo! Where's your asymptote for your parent function?
Zero.
My asymptote is at y equals 0, and I just make a dotted line, and I go that way. Now, we know that our shift points, and I noticed some people have done this when they make this table. They know that your shift is going to be, not that, your shift is going to wind up as x plus 0, and then y, what was this, plus 2. So people are knowing just to add those values right there if you want. So when I shift this, the only thing I do is just move up the graph 2 spots.
But no, it has to be straightened out.
Yes, I just cheated and just moved the graph.
Rewrite out.
Yeah, if you want. What's 2 plus 20?
Oh, wait, you're right.
All right. Where's your new asymptote now? 2. In this example, finding the y-intercept is easy because we already had the y-intercept and it didn't get shifted off of the axis. It just moved up. Some of the problems we did last night, finding the y-intercept wasn't as clean. I know that you could probably figure it out because your value of x is always going to equal 0 at the y-intercept. You could work your way through one of these problems and solve and just substitute in for 0. It's not that bad, but sometimes if it starts to get to be a really, really crummy number, I won't ask you to find the y-intercept unless you have a calculator for that. If it's something clean like this, I'd ask you what your y-intercept is because you could find it easily. Does that make sense? Is it fair? I hope. What's my domain and range then? Yes, sir.
Domain would be all real, and then range would be y is bigger than 2.
Good. And if you had a question,
Yeah.
oh, sorry.
If there's a question like there was on the last test before the finals, like if you gave us like the graph and asked us to find the equation, we would just like find the h and k,
Yep.
reverse that, and then how would you do the rest of the equation, the parent graph part?
It's a lot tougher to do a parent graph to figure out what the multipliers are on exponential than it was for what I was giving you.
So there wouldn't be a question like that?
I don't know if I'd have to make one that makes sense. I haven't really thought about making one like that yet.
Okay.
I'll try and I'll show you. I'll give you an example. Yes, ma'am.
Thanks.
Are we having a non-calculator part and the stuff on?
Yes. Let's do it. Now, let me show you a nice little trick. You might have started to pick this up. The parent function's y-intercept. Where is it?
A.
Hey. Sorry, I tried to. Is your A value? Do you agree on that?
Yes.
Your parent function, horizontal
0.
asymptote, is where?
0.
Y, I was just going to ask, make sure you not just say 0, make sure you say it's at y equals 0.
Okay.
Now, as you went through these ones last night, you might have recognized that your shift asymptote,
Okay.
it was where?
Okay.
It's at k. Your shift asymptote is always at y equals k. Your domain for every one of these problems was always what?
All real.
All real. My domain was always all real. The range was always bounded by k, wasn't it?
Yeah.
Now, depending upon the a value, allowed you to decide which way the range was going. Did you notice that? Look at this problem. What's your a value?
5.
It's 5. Which way is your range going? Is it greater than or less than your asymptote? It's greater than.
So whether A is positive or negative decides whether it's greater than negative.
Yeah. What's your a value? Is it positive or negative? So which way did your asymptote? Or was it above the asymptote or below?
Above.
Above. What's your a value?
Negative.
Negative. Was it above or below the asymptote?
Below.
It's below. The a value, in accordance with the k value, tells you your range every time. I'll show you. Your range. If a is positive, it's y is greater than k. If a is negative, it's y is less than k. This works for all exponential functions. Works for, got what?
I forgot to write the domain range on mine.
Oh, play. Seriously, the first homework assignment you screwed
Why
up.
do you think I'm angry at myself?
Don't be angry. Don't drive angry. What movie is that? Film locally. Bitch.
Cars.
Planes.
And all the automobiles? Planes, trains.
and automobiles. You missed one.
You tried.
No.
This is the Superman movie where they filmed it in the city.
Office space.
Home Alone. They filmed it in Nashville.
Yes.
Oh yeah.
If I'm looking at this problem,
Groundhog Day was filmed.
it's Groundhog Day.
Yeah.
You're right. It's Groundhog Day. It's filmed in Woodstock. If I'm looking at this problem here, you can tell me right off the bat, without doing any work, growth or decay.
It's growth. It's growth because
Growth.
B is
This is growth.
above 1, more than 1.
Why is it growth? What's your b value?
2.
Two.
More than one.
It's more than 1. Okay. Now, what's your rate? Excuse me, what's your domain?
All real.
And what's your range?
3.
Less than
Y.
Y.
Y is more than 3.
Why is less than
Y is less than 3.
Oh. Yeah.
Oops. So, just like I was saying when we were studying up for the final, you may not have to solve the entire problem with some of these things. If you understand bits and pieces of it, you can peel back to figure out what it's asking you to do. All right, so there are times when all you need to know is what's your domain and range, and could you identify which graph it might look like. This is the kind of thing you need to do. All right. Now, when we get into actually doing one with a full-on shift, like this, let's walk through this one. Well, actually, you know what? You do this one. I'm sick of doing this problem. I've done it too many times today. Actually, I don't think I've done it at all yet. Someone else has done it. So you do it, and then somebody can come and do it.
So you've been sick of doing it all.
So with any luck, we should be okay with this, I hope.
And
Yeah.
the winner who's going to do that problem is?
So A is -3,
Okay.
-2, 1. Equals -3 to the 1/2 x. Let's see here. Did you get -12, -6,
Yep.
-3?
-3 half, -3 divided by
-3 halves, and what was the last one?
-3.
Okay. We all right with that? All right. we have a starting asymptote at y equals 0, -2, -12, -1, -6, 0, -3, 2.5, 3/4, and we're doing this. To each of these points, we have to shift them left 2 and up 1.
That's rude.
So, with the one,
The y-intercept, in this case, yes, the y-intercept is 1/4. Now, Clay and I were just talking about that here. Your new your asymptote is at y equals 1. I know I'm cheating, I'm moving the graph. You guys can add in and move stuff around. It's not that big of a
why
deal.
did you move it to the left?
X minus 2.
Oh, gosh, dang it.
Well, you know what, Clay? That's my fault. I didn't see that it was a plus 2.
I know.
I thought it was a minus. I didn't read the problem, so. So in this case here, your new y-intercept, do you guys still agree it's when x is equal to 0?
Yeah.
All right. So if you substitute 0 into here, oops, you get 1/2 squared. What's 1/2 squared? What's 1/4 times -3? What's -3/4 plus 1? 1/4. This isn't that bad to find the y-intercept. The numbers are pseudo-clean. Do you agree? It's not, this is about as complex that I'd make you have to do without a calculator for a y-intercept. Anything else, you know, if it's a 2/3 one, it's just going to be awful. Whatever. Okay. Domain?
All
All
real.
real?
Range.
Y is
Why
less
is
than
less
1.
than one?
And it's less than 1 because your a value is?
Negative.
They do this.
C.
Yo hablas español. Un poquito.
You know Spanish.
Do those. It is the same problem numbers, just the next section. So far today, most people have gotten through, I don't know, most of it before they even got out of class. And you guys actually have more time than anybody else, which is weird. You guys are usually the ones that take more time. Well, you're something. I wouldn't do it special, but you're something. Remember, Clay, that's a 42.
Yeah, I'm doing right this time.
All right. I'll put it up on the board because I know books are heavy for some of you. Life is heavy.
That looks like a balloon letter.